Alright, so welcome to today's video lesson. And in today's video lesson, we're going to be taking examples on concept of work. Alright, so we have a body is pulled along a horizontal plane. So we have the horizontal plane, and then we have the body pulled. So with a constant force of 10 newtons. Okay. Now calculate the work done in moving a body of distance 20 meters. So this is the distance 20 meters. So it's moving the block or the body 20 meters. That's the first question A. So can we calculate for that? Yep. So what's the force? The force is actually 10 newtons. What's the distance covered? 20 meters. We are asked to calculate the work done. What's formula for work done? Work done is force. Work done is force multiplied by distance. And force there is 10 and distance there is 20. And that is 200 joules. So that's the work done, 200 joules. Now the second question says, what work has been done if the same forces used in the body for the same distance but applied in a direction making an angle 60 degrees to the horizontal? So block of wood, but then they said that for the same distance but applied, the force is applied in a direction making an angle 60 degrees with the horizontal, making an angle 60 degrees with the horizontal, 60 degrees with the horizontal, 60 degrees. So the force is 10 newtons, the same distance 20 meters. So what's going on? So how do we solve for this problem? Remember that the previous video we actually gave a formula for this kind of case. We said that the work done has to be F cos theta multiplied by D, and that's gonna be work done equals, what's the first, 10 multiplied by cos 30 degrees multiplied by 20. Okay, and that gives us work done equals 10 multiplied by cos 30 is actually half, that's 1/2 multiplied by 20. 2 here 1 is 2 here 10, and so you have 10 times 10, and so you have the work done to be actually equal to 100 joules. So this is the work done in this case, 100 joules, when it is applied at an angle 100 joules. So let's look at another example. So here we have this example. A man strikes a nail into a wood wooden block. I hope I'll be able to draw that. I'm still good at drawing. Alright, let me just try. So sticks the nail man, poor drawing. Alright, so a man sticks a nail into wood with an average force of, so that's where the direct direction of the force 200 newtons. So the distance also is going to move in, the nail is going to move in this direction as well. Okay, good. So that's the condition for the force definition. Okay, so if it continues to strike the nail with that force, estimate how much energy will be generated by the time the nail penetrates a distance. Let's say that's the question, 0.05 meters. So when the nail has gone through that distance of 0.05 meters, what's the energy? Alright, energy is the same as work done. So work done is the same as energy. Okay, so both measured in joules. Okay, now what's formula for work done? Work done is force multiplied by distance. And these both of them are parallel. Both force and distance are parallel to each other in this case. So force is 200 newtons. Distance is 0.05 meters. And so that's 200 multiplied by 1 over 20. That's 0.05. So 0 cancels out 0, 2 here, 1, 2 here, 10. So basically what we get is 10 joules. So the work done here is actually 10 joules. So that's the work done, 10 joules. All right, good. Let's take one more example before we go. All right, let's see this example before we end this video lesson. So let's say that you would have a block like this, then it is actually inclined. The force that is acting on this object is actually inclined at an angle, let's say 30 degrees, and the force acting on that body is actually 20 newtons. And this object is to actually move a distance of 50 meters. All right, so the question now is, what's the work done? What's the work done? Now, just like the example that we looked at previously, in this kind of case, we actually have the work done to be actually W equals to F cos theta multiplied by the distance D. And if you can remember this formula, then you have to go through the process of deriving the formula by just saying theta, then F of X, then this becomes the adjacent opposite, then use your SOHCAHTOA and you'll find that. So you should be able to do that. We've done that in the previous video. All right, so we have W equals what's our F? Our F is 20. That's multiplied by cos, what's our theta? Theta is 30 multiplied by the distance. Distance is 50 meters. That's 50. And then we have W equals 20 multiplied by cos 30 is actually 0.8660 multiplied by 50. So if you multiply these three things using your calculator, what you should get is 866 joules. So you're going to get 866 joules. So this is how to calculate for this kind of case. So we looked at two cases in this calculation of work done. So we have the first case is actually W equals force times D, and this is where the direction of the force and the distance is actually the same. So when both the force and the direction are in this and the distance is in the same direction, then the second case is actually W equals to F cos theta multiplied by D, and in this case this is where the force is at an angle with the distance covered. So that's when you use this formula. All right, good. All right, so you can lay your hands on different questions and actually do them. So but in the next video I'm going to be taking questions on very complex problem and concept of work. All right.